So this is us looking at the Napier Bluffs job. We had a survey flown last year by the Hawke's Bay Survey Company, and they've produced this mesh model of the entire bluff surround. We've been asked to look at a particular risk issue, which is, if I zoom in on it, we have this, we're calling it a small flake, but the dimensions of this are about 5.5 meters from top to bottom, 2.5 meters wide and 1.5 meters thick. So it's about 40 or 50 tons worth of flake. I think that's a nice way of putting it. What we can do using the Pix4D Online tool is this process where we draw a line and we can actually interrogate it for a cross section. So what we've done is we've done the elevation profile. So this is the elevation profile for this feature. You can see as I move it around on that section, I can tell you exactly what the dimensions are in terms of from the beginning of the section right the way down to the road level. We've actually used this cross section to look at some rockfall analysis, but it's pretty clear that I mean, this is a long way down. So this any rocks falling from this point will take 2.5 seconds to get down to this intermediate bench, and they'll be going the better part of 45 kilometers an hour or 55 kilometers an hour by the time they get over there. And I think when they come down the road, they've slowed down a little bit. There's a little bit of a skip bounce potentially, and they'll be going as much as maybe 40 or 42 kilometers an hour by the time they get through to this point. So there's been some question as to where we should put some catch attenuation structures, something similar to containers at the bottom to protect the port assets. At this stage, I understand the intention is to put the containers along the bottom on the far side of the road because there is a concern that some of the material coming over this lip may be actually too high. It's not likely, but there is a possibility that it could be too high to get captured by certainly one high bench, one high container. However, it is worth noting that we do have a very wide bench here. We can see that it is, well, it's essentially 10 meters wide, the bench that's there. It is a rock bench. You can see here, maybe a little bit blurry, but there is actually a rock shelf in here as well. But this is a completely accessible shelf that you can climb up from this existing car park here. Although there's bush and vegetation in the way, it does look like it's a vehicle accessible bench. So there is an opportunity potentially to bolster the outside edge of this bench with some soft debris, or even fill up the potential impact zone with some very, very loose sands or gravels or those kind of things, so that we can maybe actually arrest the potential fall of this flake on the bench rather than having it skip through. Failing that, we are going to need to fill the containers on the other side with at least I think probably about 25-30 tons of debris inside of the containers, so that they don't get toppled over if they get struck by a stone. Our assumptions are that the stone that might result from this coming through could be as big as maybe 1 or 1.2 meters across. So we're thinking about 4 tons. 4 tons moving at 12 meters a second is quite a lot of momentum to stop in half the width of a container before it will topple over. Yeah, that's the process that we're following. It's certainly an interesting exercise looking at potential load cases, but there is opportunities for managing the risk in a number of different ways here, either by putting something on this intermediate bench, considering the concept of using containers as an attenuation on the near side, when if they get struck, they may shuffle laterally, but that shuffling means that they don't have to be quite so heavy because they will arrest the impact over a greater distance and a greater time, or sitting them against the curb here where they have a hard pin, and so they're not going to shuffle very easily, but they do have to be a little bit heavier because the attenuation time is much shorter.